So, when I was in primary school, my father used to pick me up in the afternoon on his motorbike and take me home, a ride of about 15 minutes. Now imagine being a child, sitting on the back seat, feeling the warm sunshine and breeze on your face, drifting into a trance of existential thoughts, wondering about the meaning of life, our presence in the universe, what lies beyond the universe, our reality, to be or not to be. I remember these childhood experiences of mine some time ago when someone asked Elon Musk why he does what he does in reference to his SpaceX ventures. In response, he described experiencing similar moments during his childhood, calling it his existential crisis. This resonated with me, but I didn't know they were a crisis. I'll rather call them existential reflections or simply put, curiosity. But we all know that curiosity kills the cat. So in such moments, I must stop thinking before these thoughts drive me crazy because they become too overwhelming for my little brain. I believe most of us have had these experiences at some point. Now, theology and philosophy have long sought to help humanity answer these questions. While searching for the purpose of life within ourselves is important, it is also important to look for answers beyond ourselves, out into the universe. This pursuit, this curiosity, not only expands our understanding, but also drives technology, fuels science, and inspires future generations. It creates jobs and boosts economy. It fosters international collaborations and unites global efforts to achieve something greater than any one nation can achieve alone. The dream of a sustainable human presence in space, and ultimately, the most fascinating idea of us becoming a multiplanetary species, which is also important for the survival of humanity in the long run. Now, space travel certainly isn't easy. It involves literal rocket science, but we must start somewhere. Naturally, our initial targets for planetary exploration have been Earth's closest neighbors, Venus and Mars. Have you ever wondered why we always talk about Mars, missions, rovers, even colonization? But what about Venus? It's actually closer to Earth and often called our twin. But the more we explore, the less it felt like family. Venus is the hottest planet in our solar system, and its thick, acidic atmosphere doesn't welcome visitors. The longest a spacecraft has survived on its surface, 2 hours, before being crushed, corroded, and melted. And it gets stranger if you want to settle there. A single day on Venus is longer than its entire year. The sun rises in the west and sets in the east because it spins backwards. And early missions in the 60s focused on Venus. It was, after all, our first close-up look at another planet. And while Mars is only now entering the age of aerial exploration, it was actually Venus that hosted the first ever flying machine and any other planet had. Balloon probes launched by Soviet in 1985. But all these discoveries made one thing clear. Venus wasn't the future we were hoping for. And that's when the grass started to look greener on Mars. Today, Mars is the most explored planet after Earth, not because it's easy, but because it's manageable. Mars is about half the size of Earth, with weaker gravity and an atmosphere 100 times thinner. And yet it surprises us with how Earth-like it can be. A day on Mars is about 24 hours, and it has seasons, clouds, and even polar ice caps. But it also has temperature swings that would make your head spin, literally. If you stand at the Martian equator at noon, your feet will feel like summer, and your head will feel like winter. So that's why I plan to wear shorts and a thermal cap on head when I go there. Billions of years ago, Mars lost its magnetic shield and much of its atmosphere with it. This stripped away water, exposing Mars to harmful radiations. But hope lies underneath the surface of Mars. Caves and lava tubes on Mars could shelter future astronauts and might even be home to microscopic life right now. From Earth, Mars looked like a glowing red dot. That reddish hue comes from rusty iron dust covering its entire surface. And maps from early telescopes made people believe that there were some giant irrigation canals built by intelligent Martians. But when NASA's Mariner missions sent back close-up images in the 60s, the myths faded. Instead, we found massive canyons, extinct volcanoes, and global dust so massive that it can swallow the entire planet. So landing on Mars is also very notoriously challenging because its thin atmosphere doesn't slow down spacecraft the way Earth's does. And with communication delays, there's no room for human intervention during descent. It's just pure 7 minutes of silence for mission operators, often called the 7 minutes of terror. Over the years, engineers have built smarter and more reliable systems, and missions that were meant to last weeks have stretched into years. Looking at the Mars exploration evolution, we have come a long way from orbiters circling far above to stationary landers and eventually to mobile rovers. Rovers, though amazing, are super slow. Perseverance rover, our most advanced rover, has been crawling across the surface since 2021, and it has just covered 34 kilometers. Its predecessor, Curiosity, has covered a similar distance since 2012. That's like covering a marathon in a decade. Today, NASA's Mars program is clear and purposeful. Look for signs of life, study climate and geology, and prepare for human explorers. For over a decade, bringing samples back from Mars has been a top priority for space agencies. Then there is also a reaffirmed goal of sending humans to Mars by 2030s, which has sparked a wave of global collaboration and space technological innovations. The question now is, how do we explore faster, smarter, and deeper than ever before? That's why NASA decided to test the idea of aerial exploration with Ingenuity. The first helicopter on Mars that arrived with Perseverance rover in 2021. It was small, experimental, and was only meant for 5 flights. But it completed 72 short flights and covered about 17 kilometers of Martian terror before retiring in 2024. In doing so, it proved that powered and controlled flight on Mars isn't science fiction. It's possible. Imagine now a more advanced aerobot or aerobot that can fly farther, carrying an instrument which is advanced, mapping terrain quickly, and guiding rovers directly to areas of scientific interest. That's a game changer. But designing aerobots for Mars isn't easy. Mars has low gravity, which helps because you'll weigh less there. Probably one of the reasons that why most of us would like to go there. But it also has almost no atmosphere to push against, making generating lift really tough. It requires fast spinning and larger blades or wings to carry just a small weight. So you want to design a bigger aircraft that can lift more and fly for longer, but then it also must fit inside the small rocket capsule for transportation from Earth to Mars. And add to that freezing temperatures requiring internal heating systems, communication delays, which needs smart autonomy, And there's no oxygen, so that means Earth-like air-breathing engines wouldn't work there. Everything from blade size to flight control has to be reimagined. And to meet this challenge, one must imagine breathing on Mars before planning to fly in its air. We don't just need talented engineers, we need visionaries who understand Mars geography and climate to design aircraft suited for rugged mountains or for flat plains or dry deserts or hills or icy poles or caves. By now, I think you gained a sense of Mars exploration, its history, its geography, and the exciting missions ahead. And I have a feeling some of you are already imagining your own aerobot flying somewhere in Mars. But let's rewind a little bit. Flying on Mars isn't a new dream. It's been evolving for decades, like as early as 1950s, when the visionary von Braun, who built rockets for the moon, proposed Mars planes. And in later decades, researchers explored fixed and foldable wing gliders that could glide across the Mars and collect data for a few hours and then crash. They were fast, far-reaching, but they couldn't stop, hover, or had a second chance. Part of the challenge is they needed long runways, and Mars doesn't have runways. Not yet, but maybe one day. Why not? And then came a shift in the 2000s. Attention turned to vertical takeoff vehicles, rotorcraft like hexacopters that could hover, relaunch, and explore places which rovers couldn't. They offered control, stability, and versatility on another world. And also, hybrid designs began to emerge, aircrafts with both wings and rotors. And even now, new studies are revisiting the potential of flying gliders. But here's the real challenge. Designing a Martian aerobot isn't about picking a shape and adding rotor blades to it. It requires deep thinking and structured decision making. That's why I've developed the Mars aerobot design thinking matrix based on the literature. It begins with the first question. Do you want a disposable mission or a reusable mission? Reusable mission needs vertical takeoff, long-lasting power, and smart autonomy, whereas disposable missions are lighter and simpler, lacking reusability, but must justify their costs with strong scientific value. The next big question is, will your aerobot rely on a rover or go fully solo? If it's dependent, it can be smaller and lighter, but limited by rover speed and range. And we know our current rovers are smart but slow. Now imagine pairing an aerobot with something faster like Mars Dog. It's been getting developed by NASA and Boston Dynamics, and it will move with agility over rough terrain. That could unlock new possibilities. But to truly unlock Mars, we need aerobots that fly independently, carrying their own power communication system. Yes, that makes them more heavier and more complex, but the return is great. Then comes layers of design decisions, what kind of launch mechanism it should have. Will it be launched from the ground or mid-air? Should it be powered by solar or chemical fuel? What type of aerobot you need? So it can be, will it be a fixed-wing aircraft or a rotorcraft or a hybrid, a balloon or airship, or a hopper that jumps from surface to surface, or something more futuristic like ornithopters, which are inspired by birds or insects. And what structure will it be? Will it be rigid, foldable to fit inside a small capsule, or inflatable, expanding by filling with air after landing, or morphing, where the wings change their shape during flight to suit the conditions? So that's the beauty of this matrix. It helps transform vague ideas into well-defined missions. Each design decision opens new possibilities and new challenges. And the right answer, it depends on where you want to go, what you want to learn, and how you plan to fly through the Martian skies. So what's next? The truth is, the story is still being written. The next aerobot that flies across Mars might come from NASA's lab or someone from this room, because exploration isn't just about finding answers. It's about inspiring new questions. And they say, travel opens your mind, it broadens your vision, and you never return the same. And if it's true for crossing continents and countries, imagine what happens when we cross planets. So when I sit on a calm cliff like this, diving into my existential thoughts and looking towards the horizon, I see that the grass really is greener on Mars. Not because it's easy, but because we are almost there. One more step and we are even more closer. Do you see what I see?